This is 2012, number 17. All right, we can do this by kind of plugging in values. So we want the graph of, oh, this is the graph of f. Okay. And we want to know which could be the graph of g. So we're looking to see, is this g? Is that g? Is that g? Is this g? Is this g? So we can start with the first one, okay? And then I'll give you another way of looking at it. If we say, hey, is this one here, is this g? Is it? Well, if it were, let's plug in 0 here. And we got to assume 2 is out here somewhere. We don't know, so I'm just going to put 2 there. So if I integrate from 2 to 0, I'm integrating backwards. And so if I find the area of this piece right there, I would get an area. But then I'm integrating backwards, so it's going to be negative. So I would start with a negative value. That makes sense. And then say I went to g of, say I plug in 1 here. So f of 1. What would f of 1 be? Well, f of 1, I'd integrate from 2 to 1. So now I'm going to go to 1. So I'm getting the net area here. But since I'm going backwards, it's going to be negative. So I'm going to get a smaller negative value, which makes sense. That looks like it works, right? Then let's plug in 2. I'm just plugging in random values, assuming this is 2. The net area from 2 to 2 would be 0. And look, it is 0 there. And then let's plug in a 3 as I move to the right. So if I start integrating to the right, my area gets bigger and bigger and bigger. And so it keeps increasing. So that one looks like a great candidate. That's what looks right to me. Let's check out this one. Again, let's assume 2 is there. If I integrate and I plug in 0, f of 0, well, f of 0 should be a negative value, right? So I'm going to integrate from 2 to 0. So assuming this is 2, look, that net area is going to be negative. But since I'm going backwards, it comes out positive. So the integral from 2 to 0 would be positive. So f of 0 should be positive, but it's negative down here. So that doesn't work. That one's wrong. Okay? C. Could C work? Let's take a look-see. Look-see, get it? Look-see. Assume this is 2. And we're going to see if we have an issue with this. Let's look at f of 0. What's that going to be? Well, f of 0 is going to be integral that way, right? And it's the net area, which is positive, but we're just going backwards, it's negative, so we're down here. This looks like a candidate, right? Let's keep going. Let's go to 1, 2 to 1. So if we look at f at 1, so for these, you just process through these and you start understanding these better. I know it's kind of tedious. I'm taking a long time. But f of 1 would be the integral from 2 to 1. So it's that net area. And we're going backwards, so it's negative, right? And it's negative here. If we plug in 2, again, 2 to 2 would be 0. This looks like it might match. So let's leave C as a contender, and we'll see if it matches or not. Let's look at D. D has the same problem as B. If we take this to be 2, and we integrate, we do f of 0, it's going to be 2 to 0. So we're doing the net area here, which is negative, but we integrate backwards, it comes out positive. So f of 0 would be positive, but it's negative. So we can eliminate D. And then E, I'm going to just, to save time, I'm going to show you why E doesn't work. So again, we're going to assume this is our 2 point. So if I do f of 3, f of 3 would be integral from 2 to 3. Well, the integral from 2 to 3, that's a negative net area. It should be negative, right? But the graph here is positive, so that doesn't work. We can eliminate that one. So now, is it A or is it C? That is the question, A or C. Is it the lady or the tiger? Okay. This is where a little more thought process comes into play. If you look as we move across and we do areas, as I move each little notch across, do you see the area changes at a consistent amount? Those rectangles have all the same area. That means as I move left to right, the Y value or the net area increases equally. And that's what this shows. It's a nice even increase as I move left to right. Okay, but if I look here, look at the area of each region. Do you see as I move across, as I take net areas, the area becomes bigger and bigger? That means as I move left to right, the net area should increase more and more each time. That means as I move left to right, it should go higher and higher each time. It should be curved upwards because the amount you're adding each time is getting bigger, each little space. So that one doesn't match. Okay, that's a lot of work, what we just did. There's got to be an easier way. There's got to be an easier way. Maybe. Let's see. Let's see if there's an easier way. So these practice problems are really great because it makes you really think a lot more. I'm given f of x. Can I find f prime of x? Well, according to fundamental theorem, the integral from a constant to x, I just plug in x. That's g of x. So this is really f prime of x, right? F prime of x. What does that mean? This is f prime. 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 Well, if that's the case, check this out. F prime is negative. No, yeah, f prime is negative. If a function is negative, or if the derivative is negative, then the function is decreasing. Is this decreasing? No, it's increasing. Another way to look at it, f is always increasing. Therefore, f prime should always be positive. Doesn't work, f's negative. Doesn't work, f's negative. Doesn't work, f's negative. Much easier that way, huh? Well, then both of these work. Watch this. F is always increasing, so therefore f prime is always positive. Always positive, always positive. Now, here's where it gets, well, you could do this without doing this next step. What is this saying? The derivative is constant. That means the slope of the line everywhere is the same. And that matches. The slope everywhere is the same. Because the derivative is the slope of the tangent line there, slope of the tangent line there, slope of the tangent line everywhere, the slope of the tangent line is equal. Therefore, it should be a constant. So therefore, we can look at it and know it should be A. Okay, because this one, as we move across, the slope should get steeper. F prime gets bigger and bigger. But look, the slope at each place doesn't get bigger. To get bigger, it would have to start to curve upwards. Another way to look at this, here, f prime is increasing, right? F prime is increasing. If f prime is increasing, that means f double prime is positive, meaning f should be concave up, but clearly it's not concave up. That's not. So we can eliminate C for that reason. So that's probably the easier way to look at it as opposed to the first way.